So this question related to thermodynamics was asked in JEE in 2021. That is 5 moles of an ideal gas at 293 Kelvin is expanded isothermally from an initial pressure of 2.1 megapascal to 1.3 megapascal against a constant external pressure of 4.3 megapascal. The heat transferred in this process is. तो हमें heat transfer निकालनी है इस process में, and this is an isothermal process. For isothermal process, we know that change in internal energy is zero. So as per the first law of thermodynamics, delta U is equal to Q plus W. So Q plus W equal to 0. That means Q equal to minus W. तो अभी हमें जो है इसका work done for finding the heat transfer. Okay. Now work done के लिए जो है हमें देखना होगा whether this is a irreversible process or a reversible process. Okay, because isothermal process can be reversible or it can be irreversible. But because this process is carried out against a constant external pressure, that shows that it has to be an irreversible process. Because for reversible process, the gas pressure is always nearly equal to the external pressure during the expansion. Okay, but here it is a constant external pressure, so this is an irreversible process. So formula for work done for an irreversible process is minus P external into V2 minus V1. But initial and final volumes are not given to us. We are given the initial and final pressures. So we will apply the ideal gas equation, that is PV equal to nRT. And by this equation, we can find out the value of V1 is equal to nRT upon P1 and V2 equal to nRT upon P2. Because temperature remains constant during the process. So this formula becomes minus P external into, in place of V2, we will write nRT upon P2 minus nRT upon P1. Okay, now we will put the values. The pressure, external pressure is 4.3 megapascal, so minus 4.3. We need not change the unit because this pressure unit will get cancelled out. Into nRT, N is 5 moles, into R is 8.3 joule per mole Kelvin, into temperature is 293 Kelvin, upon P2 is the final pressure, that is 1.3 megapascal, minus nRT, that is 5 into 8.3 into 293 divided by, this is P1 is the initial pressure, that is 2.1 megapascal. So megapascal will cancel out from megapascal, so this unit will not matter. Now this will come common, so we will get 5 into 8.3 into 293 into, this will be minus, into 4.3 into 1 upon 1.3 minus 1 upon 2.1. So this decimal we can replace and we can multiply by 10, so this will become 43. And finally when we calculate, it will come to minus 15,340. This will be in joules. Okay, but we have to find in kilojoule, so this will be minus 15.3 into 10 to the power 3 joule. So for with nearest integer will be minus 15 kilojoule. Okay, so the answer is, this will be plus, it will become plus because this is work done. Now Q equal to minus W, so Q will be equal to plus 15 kilojoule. Okay, so our answer is 15 kilojoule because we have to find the heat transfer, not the work done. Thank you and wish you all the best.